Arkadaşlar, let us have one example with the convolution formulation. Let me write the convolution formulation again. Y of n is equal to x of k times h of n minus k, okay, and k is from minus infinity to plus infinity. So we will perform a little bit more complex problem here, okay. Let us have this function, which is like 1 over 2 to the power n un, okay, and h of n is going to be like, let's say, u of n, okay. How should I approach to this problem? What was the first step? Convert this into x of k, convert this into h of k, and take the reflection and then do the shifting and then multiply overlapping values, corresponding values, add those multiplications, and then finally write the summation result, to the y signal or sequence on the sample of n. N means the amount of shifting, okay? Amount of shifting that we have done. So these are the steps that we are performing. Let me do it one by one. First step. Now I'm gonna draw x of k. It is 1 here, 1 over 2, 1 over 4, 1 over 8, and so on. This is k. This is 1, 1 over 2, 1 over 4, 1 over 8. This is x of k, okay? So what is y of h of k? Hop, 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 hop. Everything is 1 because it is u of n, u of k. This is h of k. How about if I take the reflection of this? This is 0, 1, 2, and 3, and so on, and 0 all over on the negative side. If I take the reflection, then I will have this, okay? Now it will be 0, minus 1, minus 2, minus 3. What is this right now? H of minus k. So these are the first two steps, okay? What did I do? I took x of k, I took the reflection, and I wrote x of h of k right now. What is next? Now I should start shifting, okay? After the reflection, I should start shifting. Now, arkadaşlar, this was my signal, okay, 1 over 2 and such, and this was my reflected h of k. For example, this is 0, 1, and 2. If I shift h of k, h of minus k, if it's like minus 1 minus k, this will be minus 1, okay? Minus 1, minus 2, minus 3. Is there any kind of multiplication overlap over here? So minus 1, minus 2. All these values will be multiplied by zeros over here. So there is no output for minus 1 or minus 2 or other negative values, and they are all 0, okay? My output will be all 0 before 0. Okay, so this is one thing that I first observe when I do this multiplications. What is next? So if I start moving to the right, okay, this is not minus 1 anymore, this is 1, okay? 0 and -1. Now we are inside the function, okay? This was 1, 0, 1, 2, and 3. Now I'm inside my function. What am I doing here? I'm multiplying 1 with this one, and this 1 at 0 with this one, okay? So can I do this for all possible n's? There are infinite number of n's, right? Because this is like infinitely long signal. This is an infinitely long signal. I cannot do it by one, like shift 1, see the multiplications. Shift 1, see the multiplication. I will do a couple of examples and then I will show you how we should proceed. Okay, so if I would like to write h of 0, what is the result? 1 times 1, which is 1. If I say y of 1, that means 1 times 1 over 2, okay? 1 times 1 over 2 plus 1 times 1, okay? Okay, let's say, yes, 1 times 1 over 1 times 1, this is x, this is h, this is x, okay, 1 over 2, and this is h, x times h, 1 over 2 times 1, 1 times 1. Now it is 3 over 2. How did I do it arkadaşlar? I multiplied 1 here with this one, 1 by 1, 1 over 2, and then I will multiply this one with this value, okay? So I got, how about y2? What should I do? Now this will shift like this. Okay, this is 2, 1, 0, -1 to the right, to the right and to the left. What am I going to do? 1 over 4 times 1, 1 over 2 times 1, 1 times 1, right? 1 times 1 plus 1 times 1 over 2 plus 1 times 1 over 4, which is equal to 8 over 8, 4 over 8, 2 over 8, which is like 14 over 8, right? 14 over 8. This is 8 over 8. This is 4 over 8. This is 2 over 8. So it will be 14 over 8. So we cannot do this for infinite number of cases. What should I do next? What should I do with the formulations? Let me try to explain to you how I approach to this problem. I write from -infinity to a certain point, okay? So from -infinity to k, I'm gonna write x of k times, so the original formulation, let me write this. The original formulation was this, right? X of k times hn minus k. So this was my original formulation. So what am I gonna do right now? I'm gonna write this one using the formulation. How was my formulation? It was u of n, now it is u of n minus k. Okay, what is this part? 1 over 2 to the power k times uk. uk is represented like this is a step function, and it's like everything is represented after 0, right? 0, 1, and 2, and 1 over 2 to the power k. So I'm going to write this formulation right now. So this is u of k. This is u of n minus k. What does u of n minus k? This was u of n minus k when n is equal to 2. Okay, so now if I write this like that, I will say 1 over 2 to the power k. Because this is u of k, k should start from 0, because this one says I can only have values after 0, 0, 1, 2, and afterwards. How about this point? Can I write infinity here? Am I performing the multiplications up to infinity? No, I'm multiplying everything up to this shifting point, which is n. Okay, that's why I write n here. Okay, times 1, which is coming from this one, right? This one actually tells me like k, n minus k should be greater than 0. K will be less than n, okay? Or less than or equal to n. That's why we have this one here. So this k equals 0 comes from uk, and k equal up to n is coming from this part, n minus k, which is k is less than n. So then I will have from k equals 0 to n, I will have 1 over 2 to the power k. And finally, what do I have? I will have my y of n equals from 0 to n, I will have 1 over 2 to the power k. And using the formulations of this multiplications, as you can see here, 1 times 1 over 2, 1 times 1 over 1, 1 over 2, 1 over 4. So it will be, let's say, 1 plus 1 over 2 plus 1 over 4 plus 1 over 2 to the power n, right? So this is what we will have, and using the infinite sum formulations, we can Arkadaşlar, if you look at the finite sum formula, this is how it is given from k equals 0 to n minus 1. And if I have alpha to the power n, the result is going to be 1 minus alpha to the power n divided by 1 minus alpha. Okay, so what is our alpha here? 1 over 2. So what is our n here? What is our n minus 1? It is n here, right? So what should I do with the formulation? For this one is equal to 1 minus 1 over 2 to the power n plus 1, right? So this is this should be increased by 1. So I'm going to increase this to n plus 1, okay? Divided by 1 minus 1 over 2, which is like 2 times 1 minus 1 over 2 to the power n plus 1. For n greater than or equal to 0, this is the case. For n less than 0, yn is equal to 0. Okay, this is how we solve such a convolution problem. And this is all about this video, and then I will continue with this continuous time integrals, convolution integrals, and then in the class we will perform some convolution exercises together.